Good morning, all. We are going to see what are the controllers present in blood glucose monitor. First thing what you have to know is what is a blood glucose monitor? Blood glucose monitor is a medical device which is used to measure the concentration of glucose in a blood. So it is in simple terms we can say it is a medical device which is used to measure the blood sugar levels. So when we have a medical checkup or regular checkup, we used to say that a diabetes checkup or sugar level checkup monitoring. So this device is majorly used in these things to monitor or to measure the concentration of glucose in our blood level. So the above diagram is something which is known as a advanced blood glucose monitor. So it uses various types of controllers. So we are going to see one by one controllers which are being used in blood glucose monitors. So controllers in blood glucose monitor. What are the controllers are present? First thing, controllers are used to display information, store information in a blood glucose monitor. The first thing what a controller primarily is it's going to get the input from the user. So it's going to just detect analog to analog signal and going to convert it to a digital signal, then just have a check, a calculation whether the blood contains normal level of glucose or the amount of glucose is very high, going to detect. Then it's going to display it using a LCD screen. So these are the things what the controllers is going to do in a blood glucose monitor. So common microcontrollers which are used in a blood glucose monitors, ARM Cortex M, the version is the thing microcontroller uses STM32. So ARM is nothing but advanced risk microcontroller. So for it is a not an open source, it is a closed source microcontroller, licensed version of microcontroller. So we are using STM32 in most of our blood glucose monitor. Then we have Texas Instrument microchips PIC16. PIC16 is nothing but peripheral interface computer. To display our result, we are using PIC16 or PIC18. To the advanced models use PIC18. PIC16, that is PIC16 is used in the older versions. Then we have Atmega AVR. So to in some advanced micro and advanced blood glucose monitor. So these types of Atmega AVR is used in our blood glucose monitors. So ARM Cortex and STM32 and PIC18 Atmega AVR is used for displaying, storing, and calculating the things, and it is also connected with the mobile phone. So the user or the patient can get the reports in the mobile phone itself. So we have PIC16 microcontrollers in glucose monitor. So why we are using peripheral interface computer 16 microcontrollers? So what are the advantages in PIC16? So this PIC16, if you go and see any of the blood glucose monitor device, each and every device is embedded with this microcontroller or PIC18. So both have similar properties. So first we'll see what are the properties there in PIC16, peripheral interface computer 16 microcontroller. So the power consumption is very low. That is, not need high power. So it consumes very less power. So very less power is consumed, the device capacity or the device life will be very long. Then we have integrated ADC. Integrated ADC is nothing but analog to digital converter. So the blood sample input which you are giving is an analog signal. It has to be processed and it has to be converted into a digital signal for the device to detect the concentration of glucose. So the signal what we are giving is an analog signal. It has to be progressed or it has to be transformed into digital signal so that the device can understand. And again, the device has to convert the information or it has to display the information using a LCD screen so that the user can easily understand readable information. So it has flash memory. Flash memory means to store the data, to store the results. So we have the previous result, right? So whatever we have tested in that particular time, that results will be shown on the screen. So we need a flash memory. So PIC16 peripheral interface of all these properties. So we are going with this PIC16. So next, fast time real response. The response will be very soon. That is, it will be we don't need to, there will be no delay. So delay propagation will be very less. As soon as the strip has been inserted and the blood sample has been tested on it, immediately the result will be displayed on screen. There is no any delay time. Within 1 to 2 fraction of second, the result has been displayed in the LCD screen. So it is reliable, robust. Robust is nothing but we have in both the human and the device has been integrated. With integrated means the both are working together, and we are receiving and we are reaching an output. So it is robust and reliable design. So reliable design is nothing but there is no be error. It will be error free. There will not be much error in things. So it is error free, reliable. So there is no delay. So delay propagation is very less. So immediate response or immediate reply will be getting, and it has integrated ADC. One of the main advantage of peripheral interface, it is integrated ADC. We don't need to connect it to any other device for the signal to be converted from analog to digital. It has integrated ADC. It has flash memory, so the results will be stored there, and the power consumption will be very less. So the life will be very high. It has a long life. Then the key things we have to know about the PIC 16 models. So key means what are the other versions it has. So PIC 16 F877A is a type of microcontroller. So it is for we are relying on this for communication. So it converts. What communication means? It is going to convert an analog signal, that is an analog blood sample, into a digital input so that this device can easily read it. So we are using PIC 16F877A microcontroller for this analog to digital conversion. Then we are having PIC 16F887 model for peripheral communication or for memory, flash memory storage. So as the input results to be stored in the data, stored in the memory, we are going for PIC 16F887 as a flash memory. So what are the results? So once the data has been converted from analog to digital for easy for the device, then that particular value is being stored using this particular model of microcontroller PIC 16F887 controller. So it stores the value and it does some basic calculations. So is this concentration of glucose is lesser than the original, or like we have glucose level should be 80 to 120. So it comes between this range, or it be beyond this range, it is or below this range, everything this will do. Then we have compact for low power. We are using PIC 16F73. The power consumption should be very less. So in whatever design we are designing a device or any system we are designing, one of the main thing we should realize, it should be very stable. So more than efficiency, that is my device is 100% efficient. We don't need to go for 100% efficient. Even though it is 99% efficient, 98% efficient, is it power consuming? How much power consuming? We have the, that is a factor we should go. Is the power consumption is less, so it can be relied on the power. Then the same thing, it has to be stable. Being 100% efficient for a short duration, it is not preferable. Which is preferable is being 99% or 98% efficient is okay, but the stability should be long. The device should be more stable. So that's why we are going PIC 16F73. It is compact. The microcontroller size is very compact. It is in nanometers ranges. Then it is low power consuming is very less. So it also, I say, as power consumption is less, the life of this device will be more. So we are going. So these are the PIC 16 very important key features we are using is PIC 16F8771 for unlock the digital conversion of the input. Then we are going PIC 16F887 for the memory, flash memory display. Then we are going PIC 16F73 for its compact and low power. Then this is the block diagram. So you can see test strip interface. Test strip interface is nothing. This is PIC 16. So the center block is PIC 16 microcontroller. So we have a test strip. So in that test strip, there will be a slight ash color surface or yellow color surface depending on the test thing. So there is something where you need to place a drop of the blood from the patient's body. So which blood is used from for which person you are going to have the glucose check. So from that person's blood only, you're going to place on the test strip. So it is having an interface with the microcontroller PIC 16. So we are having power supply. Power supply is battery. We don't need any external power supplies like we don't need present any monitors or digital thing. Yes, since a battery is enough, 5-volt battery is enough. Then PI 16 is going to do some all memory interface. So it's going to just have a check. Then if the then after once the all the calculation, after all analog signals have been converted in digital, and once all the calculations has been done, the display is going to display in the display unit LCD board. So in the device, on the top of the device we have a LCD board. In that the display will be devised. In our blood glucose monitor, we even have a buzzer sound. So that is the thing which is there. So once the calculations have been done and the final results has been published on the display unit, so we will hear a beep sound from the buzzer. So that's why a buzzer is there. Then we have a communication module. Communications module in some advanced state, in even our blood glucose monitor as this communication, that is it is being integrated with our mobile. So that means we will receive a message from the device that this is our blood glucose level, whether it is normal or we have a low blood glucose level, whether our blood glucose level is in the border or high, everything. We have pre-diabetic stage, diabetic stage. So everything will be displayed, will be sent through a message in a mobile phone. So we having a buzzer thing so that our results have been, everything has been published. Then the results, once the result published, we'll see through the LCD display. Then we also have a SMS through getting, we'll get the SMS in the mobile phones. So functional block diagram, the components, power supply, sensor interface is nothing but the tester being interfaced with the PIC16 thing. Then we have analog to digital converter, the blood sample, which is analog signals, it is analog data, it has been processed and converted into a digital thing. So we have the microcontroller unit. Microcontroller unit is nothing but the PIC16 thing, peripheral interface computer unit. Then we have a LCD display. So the display range will be 32 in some devices or 16 in mm, everything. 32 mm, 16 mm is about the device thing. So LCD display will be something most common thing which is used in each and every devices. Then we have memory, flash memory to display to, sorry, to store, not to display, to store our things. We have flash memory. So communication module, so that we'll receive SMS in our mobile phones. We have user buttons. User buttons is that if there is any error in these machines, for example, if in some cases while keeping on test strips for a very long days, the test strip will not behave properly. So in that cases, we will receive as an error E1, F1. So if there is a backside of the device itself, we have something. What are the errors? If it is E1, it indicates that the test strip has been there is a damage. That means it has been moisture content. The test strip has moisture content. So the results we obtain may not be proper. So test strips has to be replaced with a new one. So we have errors also, E1, F1, F2, E2 errors. So that is known as user buttons. To know about all these errors, we have user buttons. So it will be helpful for each, and even the simple user could use this device. Not only a medical professional person can use this, even a normal person can use this device. So for that sake, we have user buttons to explain each and everything. So errors, how to use the device. So if the blood glucose range is between this thing, if it's in a diabetic stage, pre-diabetic stage, if they don't know the user buttons also, it's not a big thing. So they will get a SMS also. So once the test pins has been inserted and the display results has been displayed, so they can get the results through the mobile phone SMS also. And then applications of controllers. So as I said, what are the roles? First, data is being processed. The very first thing is data is being processed. The blood signal, so the blood sample, analog signal is processed into a digital. That is known as signal conversion. Next, memory management. What memory? So what is our value? What is the blood value? Concentration of glucose in that blood thing is being the memory thing. It has been managed. Then we have display control unit. Display control unit is nothing but the LCD screen. So all after performing the calculation, just have a comparison with the standard stored one. So our blood glucose concentration is being compared with the standard one. So it is what type? It is pre-diabetic type, it is diabetic type, or it is normal type. Everything it will be calculating, and the display, if the blood glucose is 128 or 160, everything will be displayed using the LCD screen. Then wireless connectivity. So what controller is being used? Wireless connectivity using PS16 integrated one thing. So we are going to get a SMS from this device. In our mobile phone, we are going to get receive an SMS from this device. So wireless connectivity, power efficiency. We said we are using PIC16 basically for it is power efficient. It doesn't use much power. It doesn't consume much power. So it is power efficient. It is reliable. It is very stable. So we are going with PIC16 controllers. So these are the roles what controllers are playing in our device, in our blood glucose monitor. Our controllers plays majorly 5 roles. First thing, it is going to get an analog input and it's going to process it to a digital input for the device. So our signal has been processed, our data has been processed. Then the memory management. For flash memory, so that the data should be stored and memorized. So we're using a flash memory. Then for controlling the display. So to publish the result or to enable display, we have a LCD screen. So that also being controlled. So we can see the display results on the LCD screens. And wireless connectivity, we are going to receive the value final results in our mobile through this wireless connection. We receive our SMS in our mobile phones. So power efficient, it does not consume much power. Then applications. What are the application of blood glucose monitors? Diabetes management in each and every hospital. So before going a checkup, the main thing what they're asking, what is your blood glucose level? Are you a diabetic patient? So for that management, we are using this. Then remote monitoring, it is easy accessible. So it just is a compact device and each and everyone can access it very thing. Monitoring and smartphone. So the device is integrated with our daily smartphone. So we'll get a SMS through this, right? And it is in emergency cases also we can use emergency alerts. Emergency alerts is nothing but if the diabetic stage is very more, that is, if a 400 level of glucose concentration in the blood, it will have emergency alert signal. That is, the patient has to be immediately admitted in the hospital, everything. So it has alert signals. If the blood glucose level is very low, we have another alert signals. So the alert signals also were there. So these are the applications. So the main application is to monitor or to measure the concentration of glucose level in our blood. So the controllers what's mainly used is PI16 ARM controller STM32. So in that we are going to have a major look on PIC16. Why PIC16 controller is used in our blood glucose monitor? Because it is power efficient. It converts our ADC analog data into a digital data. This blood being sampled is analog signal. It has been processed into a digital signal and the final results has been displayed using LCD screen. So it is a 32 LCD screen. Again, it's been controlled by a microcontroller PIC16. So these are the roles what a controller plays in a blood glucose monitor. Thank you.